I'm William B. Phillips, Bill Phillips. I won the Nobel Prize in 1997, Nobel Prize in Physics, and I make gases of atoms really, really cold. Time is one of the most important things we measure in modern life, not to find our way to appointments, but to navigate through the global positioning system for high-speed synchronous communication. We need really precise timing. And the best kinds of clocks for doing that timing are atomic clocks. So every clock has some sort of a ticker. A grandfather's clock has a pendulum that swings back and forth. A quartz watch has a vibrating quartz crystal. The best tickers are atoms. And the reason they're the best tickers are that the ticking frequency is very little affected by outside influences. And the other key thing is that all atoms of the same kind tick at exactly the same rate. Whereas every pendulum is a little different, every quartz crystal is a little different, every atom is absolutely identical. Now the trouble with atomic clocks is the atoms are moving really fast. So what we did was learn how to use laser light to push on the atoms in such a way as to make them slow down. And when they're really slow, then you can measure their ticking frequencies better. And we got down to temperatures using laser cooling below 1/1,000,000th of a degree above absolute zero. At room temperature, we're at about 300 degrees above absolute zero. And the coldest natural temperature in the universe, the black body radiation left over from the Big Bang, is about 3 degrees above absolute zero. We're going to less than 1/1,000,000th of a degree above absolute zero, and the atoms are moving at less than a centimeter per second. With that, you can make incredibly good atomic clocks. So by using laser cooling, we've been able to revolutionize timekeeping.
We all want to make sure that our food is safe, but doing that can be really hard. Looking for contaminants in raw materials is tough. The statistics are stacked against us. Today, we can only test for pathogens individually, one sample at a time. And that means hundreds, if not thousands of tests, most of which deliver a simple negative result. We needed to think about this differently.
That's why Mars and IBM joined forces, to sequence the genomes of all the organisms in the food supply chain. That's millions of organisms, but big data is what IBM is good at. The DNA and RNA sequences show you all the harmless bacteria that are found in normal, safe food.
If we do the test and the microorganisms are suddenly different, something's up. The organisms have changed because the environment has changed. It could be contaminated. And not only that, this tells us things that we never could have seen before, like where the food was grown, how it was transported, and maybe even what happened en route. Our approach to food safety just got a lot smarter.